Hello dear student, this is our next derivation, derivation number 17, which is energy stored in a capacitor, right? Basically energy stored in a capacitor formula is E is equal to Q square upon 2C. This is what we are going to derive, right? So we are charging a capacitor, which has a capacitance C, by a battery which has a potential difference V or EMF V. In the final state, once the capacitor is charged, at that time the charge on the capacitor is Q. Okay. But what happens during charging? Say we start with the uncharged capacitor. So it starts with a zero value and it increases and it takes some time to get to a value capital Q. So when it is getting charged, during the charging process, charge keeps on changing on the capacitor. So what we are saying, we assume there is a Q dash, charge Q dash be the charge on the capacitor at any given instant. कुछ एक बीच में ड्यूरिंग चार्जिंग कोई हमने इंस्टेंट ले लिया इन जनरल जिसपे कि जिस टाइम पे जो चार्ज है तो कैपेसिटर इज Q डैश. अब इस स्टेट से आप उसमें एक स्मॉल अमाउंट ऑफ चार्ज ऐड कर रहे हो dq dash. So let dq dash charge is added in the capacitor now. So what will be the work done? The work done will be when you move a charge. What is the work done? Q into V. So what you have moved? You have moved dq dash. dq dash. Right? At that time, what is the potential across the capacitor plate? That will be V dash. Don't take it this way. See, eventually the potential difference across capacitors will come as V in the final state, but currently it is increasing because slowly the charge is increasing. So you cannot keep it V here because V is the final potential difference across the plates of the capacitor. Right? It has to be some value V dash. Now, whatever that value is, V dash at that instant it has to be equal to Q dash by C because Q is equal to CV is true at all the instants. So at that particular instant when we are doing this activity, at that time Q dash is the charge and capacitor is still C, capacitance is C. So Q dash by C is the value of V dash and dQ dash. So this is the small work done we have calculated. You want to find out the total work done. So for total work done you have to integrate this. Integrate, you will get the total work done. From your variable is Q dash against which you are integrating. So what is the value of Q dash initially? When you're just plugging in, the charge is 0. What is the final value? Q. So 0 to Q, you're integrating this guy. Now C is a constant, will come out. It will become 0 to Q, Q dash dQ. 0 to Q, Q dash dQ. अब इसको इंटीग्रेट करना हमको मालूम है कि अगर हमारे पास इंटीग्रल x dx रहता है, so this becomes x square by 2. इंटीग्रल x dx रहेगा तो x square by 2. तो यहाँ पे q dq है तो क्या रहेगा? q dash square by 2. ठीक, तो ये हो जाएगा w इक्वल टू 1 by c q dash square by 2 and limits 0 to q. अब इसमें आप 0 to q लिमिट डालोगे जब q इक्वल टू 0 डालोगे तो ये 0 हो जाएगा. तो इट विल बी जस्ट q square by 2c. q square by 2c. And this is what we were intending to derive. Now there are various forms. So you can just manipulate this formula and write it in, in the form of C and V. Why? Because you can write Q as CV. So Q square will be equal to C square V square upon 2C. So it will get cancelled, half CV square. So this is in the terms of capacitance and potential difference, half CV square. Similarly, you can write this formula also in terms of Q and V also. Instead of C, you can write Q by V. When you write Q by V, so this formula would be Q square by 2. In place of C, you are writing Q by V. Q and Q will get cancelled, you will get 1 by 2 Q into V. This V will go up 1 by 2 Q into V. So these are the three forms. Now the derivation is done here. I just wanted to remind you of a small concept which we talked about in the offline class also. During this charging, something happens. And what is that important process? See how much charge the battery has moved across the circuit. Q charge and potential difference is V. So what is the work done by the battery? Q into V. Total work done by the battery, Q into V. Q charge has been moved, V potential difference, right? उसमें से कैपेसिटर के पास कितनी एनर्जी स्टोर हुई, 1/2 क्यूवी, अभी हमने डिराइव किया। अभी 1/2 क्यूवी हुआ ये क्यूवी, तो बाकी 1/2 क्यूवी कहाँ गया? This is energy loss. So whenever you charge a capacitor, obviously charge is moving in the circuit, so there will be some loss in the heat, right? So that will be QV minus half QV, 1/2 QV. So you can see 50% energy is lost as heat in charging. This question came in MSc CET as an objective, I think pretty recently. Okay? Thank you very much.